On June 10th, 1944, at 0600 hours, Vice Admiral Takeo Kurita stood on the bridge of the heavy cruiser Atago, watching dawn break over Tawi-Tawi anchorage in the southern Philippines. The fleet assembled before him represented Japan's last operational carrier strike force: 3 fleet carriers, 5 light carriers, 5 battleships, 13 cruisers, and 28 destroyers. On paper, it looked formidable. In reality, Kurita knew it was a carefully maintained illusion. The carriers were there. The aircraft were mostly there. But the pilots flying those aircraft had an average of 6 months training. Most had never made a combat carrier landing before yesterday. Some had fewer than 100 total flight hours. The Americans they would face had been fighting continuously since Guadalcanal. Kurita had received the intelligence reports. American task forces now operated with 15 to 18 carriers per group. 15 carriers in a single formation. Japan's entire operational carrier fleet was 8 ships, and half of them were converted merchant vessels with wooden flight decks that would splinter under bomb hits. The mathematics were impossible. The outcome was predetermined. Yet, orders from Tokyo were explicit. Engage the American fleet, destroy their carriers, stop the advance toward the Philippines. Kurita understood what those orders really meant. Die trying, because trying was all that remained. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The carrier crisis. Japan faced in mid-1944 had roots extending back 2 decades to decisions made when most of the men now dying in the Pacific were still children. In 1922, the Washington Naval Treaty had attempted to prevent another naval arms race by limiting battleship construction among the major powers. The treaty assigned ratios. For every 5 capital ships America and Britain could build, Japan could build 3. The ratio seemed reasonable to Western diplomats. It seemed insulting to Japanese naval planners. Japan was being told it could never achieve naval equality with Western powers. The restriction burned. Japanese strategists spent the 1920s searching for ways to overcome the treaty limitations. They found their answer in aircraft carriers. The Washington Treaty limited battleships but said relatively little about carriers. Japan could build carrier strength without violating treaty obligations. They laid down Akagi in 1923, converted from a battlecruiser hull. They laid down Kaga in 1923, converted from a battleship hull. They designed Ryujo as a light carrier in 1929. They designed Soryu and Hiryu as purpose-built fleet carriers in the early 1930s. By 1941, Japan had 10 carriers operational or under construction. They had developed carrier doctrine through years of fleet exercises. They had trained pilots to standards no other nation matched. They had created the most formidable carrier striking force the world had ever seen, and they believed that force would give them victory in any Pacific war. American naval planners watched Japan's carrier development with concern, but without panic. The United States had aircraft carriers. Lexington and Saratoga, both converted from battlecruiser hulls, had been commissioned in 1927. Ranger, a smaller purpose-built carrier, joined the fleet in 1934. Yorktown and Enterprise, modern fleet carriers, were commissioned in 1937 and 1938. By 1941, the U.S. Pacific Fleet had 7 carriers, fewer than Japan's 10, but the American ships were newer, larger, and carried more aircraft. The balance seemed manageable. Naval War College studies suggested that in carrier versus carrier combat, the side that struck first usually won. Training and doctrine mattered more than numbers. American confidence rested on the assumption that American pilots, American aircraft, and American carriers were qualitatively superior, even if numerically inferior. That assumption survived until December 7th, 1941, when 6 Japanese carriers launched 183 aircraft against Pearl Harbor in the first wave. followed by 167 aircraft in the second wave. The attack sank or damaged 8 battleships, destroyed 188 aircraft, killed 2,403 Americans, and demonstrated that Japanese carrier aviation was not just equal to American capabilities, but potentially superior in execution, coordination, and tactical skill. The shock reverberated through American naval planning. Japan had just executed the most successful carrier strike in history. Their pilots had hit targets in conditions that should have made accurate bombing nearly impossible. Their aircraft had achieved surprise despite crossing hundreds of miles of open ocean. Their carriers had launched and recovered aircraft with efficiency that suggested years of practice. If this was what Japan could do, what hope did America have in carrier warfare? The answer came not from admirals or tacticians, but from shipyards and factories. Within hours of the Pearl Harbor attack, the U.S. Navy placed emergency orders for new carriers, not 1 or 2 ships, dozens. The Essex class design, already on the drawing boards, became the foundation for a construction program that would dwarf anything attempted before. 10 carriers were ordered in 1942, 8 more in 1943. The Navy requested them. Congress funded them. Shipyards accepted contracts they had no idea how to fulfill, because in December 1941, no American shipyard had ever built more than 1 fleet carrier at a time. The construction methods were slow, labor-intensive, and dependent on skilled workers who took years to train. Building 20 carriers using traditional methods would take decades. The Navy needed them in 2 years. Newport News Shipbuilding in Virginia received the first Essex-class contracts. The yard had built Yorktown and Enterprise. They understood carrier construction. They knew it required 4 to 5 years, from keel laying to commissioning. That timeline was acceptable in peacetime. It was disaster in war. The yard's president, Homer Ferguson, called a meeting of senior engineers and shipbuilders in January 1942. The question was simple: how do we cut construction time in half? The answers were not simple. Carrier construction involved thousands of complex operations, each dependent on the previous step being completed. You built the hull from the bottom up. You installed machinery after the hull was watertight. You added electronics after the superstructure was complete. Each phase required specialized workers with years of experience. Cutting time meant either working faster, which had limits, or changing the entire construction process. Ferguson had been reading about Henry Kaiser's Liberty ship program. Kaiser was building cargo ships in 60 days, using prefabrication and welding instead of riveting. Could the same methods apply to carriers? The engineers were skeptical. Carriers were not cargo ships. They required precision engineering, watertight integrity, complex systems integration. Prefabrication might work for simple structures. It could not work for something as sophisticated as a fleet carrier. Ferguson told them to try anyway. If they failed, they would revert to traditional methods. If they succeeded, they might cut construction time enough to matter. The first experiment involved flight deck sections. Traditionally, flight decks were built in place on top of the carrier hull. Steel plates were lifted by crane positioned by workers standing on scaffolding and riveted together one plate at a time. The process took months because each plate had to be precisely aligned with the plate's already installed sheet. Any error in one plate created alignment problems for all subsequent plates. Ferguson's team proposed building entire flight deck sections in a fabrication shop away from the shipway. They would construct sections 40 feet wide by 100 feet long on ground-level assembly jigs. Workers would weld the plates together in ideal conditions, with proper lighting, easy access, and no scaffolding required. Once a section was complete, cranes would lift it onto the carrier hull and workers would weld it into place. The first section took 6 weeks to build. That was slower than building in place. But the second section took 4 weeks. The third took 3 weeks. By the 10th section, workers were completing them in 2 weeks. The learning curve was steeper than anyone expected, because workers were doing the same task repeatedly, instead of constantly adapting to new situations. More importantly, the prefabrication method allowed multiple sections to be built simultaneously. Newport News constructed a fabrication building large enough to assemble 6 flight deck sections at once. While one section was being installed on the carrier, 5 more were under construction in the shop. The total time to complete a carrier's flight deck dropped from 5 months to 2 months. Similar experiments succeeded with other components: hangar deck sections, island superstructures, elevator assemblies, propulsion machinery modules. Everything that could be prefabricated was moved out of the shipway and into specialized fabrication shops. The shipway became a final assembly area where pre-built components were joined together rather than a construction site where everything was built from raw materials. The method required more space, more cranes, more coordination, but it cut construction time by 40%. Essex, the lead ship, took 20 months from keel laying to commissioning. That was already faster than any previous American carrier. But Lexington, the second ship, took 18 months. Bunker Hill took 16 months. By the 10th Essex-class carrier, Newport News had refined the process to 14 months average construction time. 14 months. Japanese yards needed 30 to 35 months for comparable ships. The speed advantage came from 5 key innovations. First, welding replaced riveting wherever possible. Welding was faster, required less skilled labor, and created lighter structures. A riveted joint required drilling holes, inserting rivets, and hammering them into place. A welded joint required positioning the plates and running a welding torch along the seam. Welding took 1/3 the time of riveting and used half the labor. Second, standardization eliminated custom work. Every Essex-class carrier used identical plans. Every component was built to exact specifications. Workers did not have to measure, cut, and fit each piece individually. They grabbed pre-made parts from inventory and installed them. Third, parallel construction replaced sequential building. Instead of waiting for the hull to be complete before starting the superstructure, all components were built simultaneously in different shops, then brought together for final assembly. Fourth, specialized work crews replaced generalist shipbuilders. One crew did nothing but weld bulkheads, another crew installed electrical systems, another crew fitted propulsion machinery. Specialization created expertise. Workers became extraordinarily efficient at their specific task. Fifth, massive investment in tools and facilities. Newport News built new fabrication shops, installed hundreds of cranes, purchased thousands of welding sets, and hired tens of thousands of workers. The capital investment was enormous, but it paid off in speed. Japan could not replicate any of these innovations. Japanese shipyards lacked the space for large prefabrication facilities. Most yards were hemmed in by cities, mountains, or harbors with no room to expand. Building new fabrication shops would have required relocating entire neighborhoods, which was impossible during wartime. Japanese industry lacked welding capacity. Most shipyards still relied primarily on riveting because they had insufficient welding equipment and too few trained welders. Expanding welding capacity required importing equipment from America or Germany, which was impossible after 1941. Japanese manufacturing culture resisted standardization. Skilled craftsmen took pride in custom-fitting components to ensure perfect alignment. The idea of using mass-produced parts that might not fit precisely seemed sloppy, unprofessional, a shortcut that would produce inferior ships. That attitude produced beautiful craftsmanship, but slow construction. Japanese shipyards lacked labor. Total employment across all naval shipyards was approximately 300,000 workers. In 1944, Newport News alone employed 40,000 workers at peak production. Adding Kaiser's Richmond Yards, Bethlehem Steel, Brooklyn Navy Yard, and other facilities, American carrier construction employed more workers than Japan's entire naval shipbuilding industry. Most critically, Japan lacked steel. An Essex-class carrier required 27,000 tons of steel plate, structural members, armor, and machinery components. The United States produced 89 million tons of steel in 1944. Japan produced 7 million tons. American steel production was 12 times larger than Japan's entire output. That gap meant American shipyards had abundant steel. If a section was built incorrectly, they scrapped it and built a new one. Waste was acceptable because speed mattered more than efficiency. Japanese shipyards rationed every steel plate. Mistakes had to be repaired, not replaced, because there was no spare steel for rebuilding. Repairing errors took time, slowed construction, and consumed skilled labor that could have been used for new work. The steel shortage rippled through every aspect of Japanese carrier construction. Taiho, Japan's most advanced carrier, was designed with an armored flight deck to protect against bomb hits. The armor required 3,000 additional tons of steel plate. That steel came from battleship construction programs that were delayed as a result. Suikaku and Shokaku, Japan's most successful fleet carriers, were designed with sophisticated damage control systems, multiple watertight compartments, and redundant machinery spaces. All of that required steel. Building one Suikaku-class carrier consumed as much steel as building 6 destroyers. Japan needed destroyers desperately to escort convoys and screen the fleet. Every ton of steel allocated to carriers was a ton unavailable for destroyers, cruisers, or merchant ships. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. American shipyards faced no such trade-offs. United States steel production was so vast that carriers, battleships, destroyers, cruisers, submarines, merchant ships, landing craft, and every other category could be built simultaneously without shortages. In 1944 alone, American yards launched 8 Essex-class carriers, 4 battleships, 63 destroyers, 26 submarines, and more than 2,000 merchant ships. The total steel consumed by naval construction was only a fraction of total steel production. The rest went to tanks, artillery, aircraft, bridges, railroads, and civilian infrastructure. Japan's entire steel industry could not have supported even the carrier program alone, much less the rest of the Navy. By mid-1944, Japanese naval construction was collapsing under resource constraints. The Onryu-class carrier program had ordered 16 ships. 3 were completed. 6 more were under construction, but progressing slowly because steel deliveries were irregular. 7 were never started because the steel was not available. The steel that might have built those carriers had been diverted to destroyers and escorts because American submarines were sinking Japanese merchant shipping faster than it could be replaced. Destroyers and escorts were needed immediately to protect the shrinking merchant fleet. Carriers could wait. Except carriers could not wait because American carrier task forces were destroying Japanese positions across the Pacific, and Japan had no carriers to oppose them. The strategic situation had become absurd. Japan was building destroyers to protect merchant ships that were carrying steel to build carriers that would protect the merchant ships. But the carriers took so long to build that merchant ships were sunk before the carriers were completed, which meant less steel for the next carrier, which meant construction delays, which meant more merchant ships sunk. The cycle fed itself. Every loss made the next loss more likely. American submarines understood this dynamic perfectly. By 1944, U.S. submarine commanders were specifically targeting Japanese merchant ships carrying raw materials. Sinking a freighter loaded with iron ore from Manchuria did more strategic damage than sinking a warship because it delayed every naval construction program dependent on that steel. Japanese convoys sailing from Korea and Manchuria to Japanese home islands were running a gauntlet of submarines that sank 20 to 30% of ships on every voyage. The steel that did arrive was often diverted to emergency repairs of damaged ships rather than new construction. Japan was cannibalizing its future to maintain its present, and both were failing. The human dimension of this industrial catastrophe became visible in the faces of young pilots reporting to carrier air groups. In early 1944, Lieutenant Junior Grade Sake Yamamoto arrived aboard the carrier Zuikaku in March of that year with 73 hours of flight time in his logbook. Before the war, carrier pilots required a minimum of 300 hours before fleet assignment. Yamamoto's training had been condensed to 7 months because Japan no longer had fuel for extended instruction or time to develop skills properly. He joined a squadron where the average pilot age was 19. Most had never seen combat. Their commander was 24, considered a veteran because he had survived 2 engagements. The squadron was assigned a 40 aircraft but had only 32 pilots qualified to fly them. Japan simply did not have enough trained aviators to fill the carriers it still possessed. Yamamoto would die 6 weeks later at the Battle of the Philippine Sea, shot down during his second combat mission by an American pilot who had 320 hours of combat experience alone. He never had a chance. None of them did. The contrast with American pilot training revealed how thoroughly industrial capacity shaped every aspect of carrier warfare. By 1944, American naval aviators were completing 18-month training programs that included 300 hours of flight time before carrier qualification, then another 100 hours of carrier operations before joining fleet squadrons. They trained on the same aircraft they would fly in combat. They practiced against instructors who had just rotated back from the Pacific with recent combat experience. They learned tactics that had been developed, tested, and refined in actual battles fought weeks earlier. The U.S. Navy was operating a complete training pipeline that took civilians with no aviation experience and transformed them into combat-ready carrier pilots in predictable timeframes with consistent quality. More importantly, the pipeline could scale. In 1942, American naval aviation trained 1,200 new pilots. In 1943, 3,000 pilots. In 1944, 5,000 pilots. Production increased every year because training bases expanded, instructor pools grew, and aircraft availability improved. Japan's pilot training capacity moved in the opposite direction. In 1942, Japanese naval aviation trained 800 new pilots. In 1943, 400 pilots. In 1944, fewer than 200. The numbers declined because Japan lacked fuel for training flights, lacked aircraft to spare for instruction, and lacked experienced pilots to serve as instructors, since most were dead or needed in combat units immediately. This training collapse intersected with aircraft quality issues that compounded Japan's disadvantages. The Mitsubishi A6M0 fighter had been magnificent in 1941. It was faster than American fighters, more maneuverable, longer-ranged, and armed with 2 20mm cannons that could destroy enemy aircraft with short bursts. American pilots who encountered Zeros in early battles reported feeling outmatched. The Zero seemed to do everything better, climb faster, turn tighter, accelerate quicker. But by 1944, the Zero was obsolete. American factories had developed new fighters specifically designed to counter the Zero's advantages. The Grumman F-6F Hellcat was heavier than the Zero, less maneuverable in turning fights, but vastly superior in other ways that mattered more in combat. The Hellcat could dive at 450 miles per hour without structural failure. The Zero's maximum dive speed was 330 miles per hour before the wings began to tear off. American pilots learned to attack from altitude, dive through Japanese formations firing, then extend away in a dive that Zeros could not follow. The Hellcat had armor plate protecting the pilot, self-sealing fuel tanks that prevented fires when hit, and robust construction that allowed it to absorb battle damage and continue flying. The Zero had no armor, no self-sealing tanks, and fragile construction. A single 50 caliber bullet through the fuel tank would ignite it. Pilots burned to death regularly because their aircraft offered no protection. Japan's aircraft industry tried to develop improved fighters, but resource shortages and production delays meant new designs arrived too late, and in too few numbers to matter. The Kawanishi N1KJ Shiden was potentially superior to the Hellcat in some respects, but only 407 were built during the entire war. The Mitsubishi A7M was designed as the Zero's replacement, but development problems delayed it until 1945, and only 8 were completed before the war ended. Japan kept building Zeros because factories were tooled for Zero production. Workers knew how to build them, and changing to new designs would have halted production for months while retooling occurred. So Japanese pilots flew obsolete fighters against superior American aircraft flown by better-trained pilots, and they died in ratios that approached 10-1 by the war's final year. No amount of courage compensated for that disparity. Bushido spirit did not deflect bullets. Willingness to die did not make aircraft faster or fuel tanks self-sealing. Young men climbed into Zeros, knowing they were climbing into flying coffins, and they flew anyway because orders were orders and Japan was losing, and someone had to try. The most profound irony of the carrier construction race was that Japan had actually understood the problem earlier and more clearly than America. Admiral Isoroku Yamamoto had warned the Japanese government in 1941 that war with America was unwinnable in the long term. He told them Japan might achieve victories for 6 months, perhaps 1 year, but American industrial power would eventually overwhelm any temporary advantages Japanese forces gained. He was not guessing. He had served as a naval attaché in Washington during the 1920s. He had traveled across America visiting factories, shipyards, and industrial facilities. He had seen the scale of American manufacturing capacity firsthand. He knew what those factories could produce if motivated by war. His warnings were ignored because Japanese military leadership believed spiritual superiority and tactical excellence could overcome material disadvantages. They believed Japanese warriors were inherently superior to Western soldiers who were soft, undisciplined, and lacked fighting spirit. They believed one Japanese carrier pilot was kit 5 American pilots. They believed Japan's carrier strike force was invincible. These beliefs were not entirely unfounded. Japanese pilots in 1941 were genuinely superior in training and experience to their American counterparts. Japanese carrier doctrine was more advanced. Japanese torpedoes were better. Japanese night fighting techniques were unmatched. For approximately 7 months, these advantages produced victories. Then the advantages eroded. American pilots gained experience. American doctrine adapted. American industry produced better aircraft, better radar, better everything. Within 18 months of Pearl Harbor, tactical and qualitative advantages had shifted to America. Within 24 months, they were overwhelming. By mid-1944, American carrier task forces operated with capabilities Japan could not approach. Task Force 58, which fought at the Philippine Sea, included 15 carriers deploying 956 aircraft. Those carriers were protected by 7 battleships, 8 heavy cruisers, 13 light cruisers, and 69 destroyers. The entire task force was coordinated through radio networks, directed by radar that could detect incoming attacks at 90 miles, and defended by proximity-fused anti-aircraft shells that increased defensive effectiveness by 500% compared to pre-war munitions. Japanese carrier forces had none of these advantages. Their radars were primitive when they worked at all. Their radio coordination was poor. Their anti-aircraft defenses relied on visual sighting and time-fused shells that rarely hit anything. Attacking an American carrier task force in 1944 was nearly suicidal. Japanese pilots faced coordinated fighter intercepts directed by radar, multiple layers of combat air patrol, intense anti-aircraft fire from dozens of ships equipped with proximity-fused ammunition, and American pilots who had seen it all before and knew exactly how to kill inexperienced attackers. The result was predictable and terrible. On June 19th, 1944, Japan launched four major strikes against Task Force 58. The first strike of 69 aircraft was detected on radar at 150 miles. American fighters intercepted at 70 miles and destroyed 42 aircraft before they reached the task force. The surviving planes pressed their attacks and were destroyed by additional fighters and anti-aircraft fire. 64 of 69 aircraft were shot down. 0 hits were achieved on American carriers. The second strike of 109 aircraft suffered similar losses. 97 aircraft destroyed, 0 hits on carriers. The third strike of 47 aircraft lost 40, again with no significant damage inflicted. The fourth strike became disoriented, never found the American carriers, and suffered heavy losses trying to return to Japanese carriers in darkness. By the end of the day, Japan had lost 373 aircraft and most of their pilots. American losses were 23 aircraft. The exchange ratio was 16-1. This was not battle. It was industrial-scale slaughter, enabled by the cumulative advantages of superior training, superior aircraft, superior tactics, superior radar, superior everything that industrial capacity made possible. Japanese pilots were not cowards. They were not incompetent. They were simply overwhelmed by systems and capabilities their nation lacked the industrial base to produce. The battle also cost Japan 3 carriers. Tai-ho, the newest and most advanced carrier in the fleet, was torpedoed by the submarine Albacore. The torpedo hit was not immediately fatal. Japanese damage control procedures should have contained the flooding and saved the ship. But a young damage control officer made a critical error. Gasoline vapor from ruptured aviation fuel lines was accumulating in the hangar deck. The officer ordered the ship's ventilation systems turned on maximum to clear the fumes. Instead of venting the vapor overboard, the ventilation system distributed it throughout the ship's interior spaces. 6 hours after the torpedo hit, an electric spark somewhere in the ship ignited the vapor. The explosion was catastrophic. It blew out the sides of the ship, collapsed flight deck sections, and killed hundreds of men instantly. Tai-ho sank within minutes. 1,300 crew members died. The ship had been in service for exactly 3 months and 8 days. 32 months of construction, 3 months of operation. Gone. Shokaku, veteran of Pearl Harbor and every major carrier battle since, was hit by multiple torpedoes from the submarine Kavala and sank 7 hours later. The loss felt personal to Japanese naval officers who had served with Shokaku since the war began. She was more than a ship. She was a symbol of Japan's carrier power, and watching her sink felt like watching an era end. The third carrier lost was Hiryu, a converted passenger liner, pressed into service as a light carrier. She was torpedoed by aircraft and sank after internal explosions detonated her magazines. 3 carriers lost in 1 day. The Americans lost 0 carriers. American submarines and aircraft had destroyed in hours what had taken Japan years to build. The mathematics of replacement were impossible. Japan had 3 carriers capable of building fleet carriers. All were working at maximum capacity. Replacing 3 carriers would require at least 3 years under optimal conditions, and conditions were far from optimal. Steel production was declining. Skilled workers were being drafted into the army. American submarines were sinking the merchant ships that carried raw materials. There would be no replacements. The Battle of the Philippine Sea effectively ended Japan's carrier capability. The ships that survived had no aircraft and no pilots to fly them, even if aircraft could be found. For the remainder of the war, Japanese carriers served primarily as decoys. At the Battle of Leyte Gulf in October 1944, Japan sent 4 carriers north as a deliberate sacrifice to draw American carriers away from the main battle area. The plan worked. American aircraft attacked the decoy carriers and sank all four. But the sacrifice achieved nothing strategically. American escort carriers in Leyte Gulf fought off Japanese surface forces anyway, and Japan's last carriers died for no gain. Zuikaku, the final survivor of the 6 carriers that attacked Pearl Harbor, went down on October the 25th, 1944. She had survived nearly 3 years of continuous combat. She died because Japan no longer had the aircraft or pilots to defend her. By December 1944, Japan had 0 operational fleet carriers. America had 32. The disparity was absolute. American carrier task forces ranged across the Pacific, attacking targets at will. Japanese forces had no counter, no ability to defend, no ability to strike back. The war continued for another 8 months, but the outcome had been decided by industrial capacity long before. In those final months, American carrier aviation demonstrated what unchallenged industrial power could accomplish. Task Force 38 operated off the Japanese coast throughout July and August 1945, launching 1,000 aircraft strikes against Japanese cities, factories, and military installations. Japanese air defenses were overwhelmed. Fighter interception was sporadic and ineffective. American pilots described missions as almost routine: fly to target, drop bombs, return to carrier, minimal opposition, few losses. The same industrial system that had built 100 carriers during the war was now using those carriers to destroy the industrial capacity of the nation that had failed to match American production. There was a brutal symmetry to it. Japan had gambled that tactical brilliance and warrior spirit could overcome industrial disadvantages. They were wrong. Industrial capacity determined carrier construction rates. Carrier construction rates determined fleet size. Fleet size determined combat power. Combat power determined victory. The lessons extended beyond carrier warfare into fundamental questions about national strategy and industrial planning. Japan had made a catastrophic miscalculation in 1941. They believed they could win a short war before American industry fully mobilized. They believed they could seize resource-rich territories in Southeast Asia that would fuel their war machine. They believed they could defend a perimeter that American forces would be too exhausted or demoralized to breach. Every assumption failed. American industry mobilized faster than Japan thought possible. The territories Japan seized never produced the resources Japan needed because American submarines sank the ships carrying those resources to Japan. The defensive perimeter collapsed under assault by forces Japan had no capacity to resist. By mid-1943, thoughtful Japanese officers understood the war was lost. They continued fighting because surrender was culturally unthinkable, and because military leadership insisted that sufficient sacrifice and determination might still achieve favorable peace terms. Neither happened. The sacrifice was immense and meaningless. The determination was real but insufficient. The peace terms were unconditional surrender. When the war ended on August the 15th, 1945, Japan had commissioned 8 carriers during 4 years of war: 3 Unryu-class fleet carriers, 3 converted light carriers, and 2 escort carriers hastily completed from merchant hulls. America had commissioned 24 Essex-class fleet carriers during the same period, plus 9 Independence-class light carriers converted from cruiser hulls, plus 77 Casablanca-class escort carriers, plus dozens of other escort carrier variants. The total was over 120 carriers of all types. The title of this story understates reality. America didn't stop counting carriers at 24. That was just the Essex class total. The actual number was so large that individual carriers became functionally anonymous, identified by hull numbers rather than names because there were too many to remember. Japan built 8 carriers in 4 years, a construction rate of 2 carriers per year. America built 120 carriers in 4 years, a construction rate of 30 carriers per year, 15 times faster. That 15-to-1 ratio explains the Pacific War more comprehensively than any analysis of tactics, battles, or leadership decisions. Industrial capacity was destiny. Japan lacked it. America possessed it in overwhelming abundance. That difference made victory inevitable, regardless of how bravely Japanese forces fought or how brilliantly Japanese commanders planned. The profound tragedy was how many people died learning what should have been obvious from the beginning. Yamamoto had warned them. The numbers were available. Anyone who studied comparative industrial statistics between Japan and America in 1941 should have understood the war was unwinnable. But institutional momentum, cultural assumptions, and strategic wishful thinking overrode rational analysis. Hundreds of thousands died as a result. Young pilots like Sakae Yamamoto, who never had a chance. Sailors aboard Taiho and Shokaku and Zuikaku, who went down with ships that should never have been sent into battles they could not win. American sailors and pilots who died defeating an enemy that lacked the industrial capacity to prevail. The waste was staggering. War often is. But this particular war's outcome was predetermined by factors that had nothing to do with courage or skill or tactical innovation. Steel production, shipyard capacity, worker availability, and resource access decided the Pacific War. The fighting simply made the predetermined outcome manifest through terrible human cost. Understanding that does not diminish anyone's sacrifice. It clarifies what they were sacrificing for and why that sacrifice, however brave, could not change the mathematics that governed industrial warfare. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.